are you?
I'm at home.
It's launch day.
Oh my God. I'm on my way. Let's do this.
Hello, everybody, and welcome. Thank you all so much for joining us today. My name is Shelby Yee, and I am the CEO and co-founder of RockMass Technologies. So we are here today live in Toronto to share our latest release, RockMass Eon. Now, this platform is likely new to most of you here, so I'll give you a runaround on how it works. There's three things that we'll use today. So the first is the chat function. So if you look at the right vertical panel and you click on the second button down, you'll see a chat function. So you can go ahead and start typing in there, tell us where you're listening in from. In our last launch event, we had people listen in from over 40 different countries. It was amazing. If you have any questions throughout the event, then if you go one button down from there, that's the Q&A session. So please feel free to ask them throughout, upvote any ones that you want asked at the end of the event. And when we get there, we'll answer them. And now the third one is the poll, so right below Q&A. And so throughout the event, we'll be asking you to weigh in on some questions, and we'll actually get started with a poll right now for you to give it a go. So go ahead and vote. And finally, we have a leaderboard. So this is on the top horizontal section of the screen, and click on the trophy. Now we will be giving out a door prize of an annual membership to a professional association of your choosing for the person who has the most points at the end of the session. You can see how you win points there, and we will announce that at the end of the event, so be sure to stick around. And then finally, if you experience technical difficulties at any point in time, you can always just give this browser a refresh, and it'll take you right back into this location. So I'll just pull up an agenda, and it'll show you what you can expect today. Very shortly, I'll be introducing a panel of mining and infrastructure experts, and they're going to be talking about Eon and the future of technology in these industries. After that, we'll unveil RockMass Eon, followed by a live Q&A about the solution. We'll then announce the winner of the door prize, so again, stick around, and this will be the official close of the event at about 1:45 p.m. Eastern. If anyone has more questions or you want to learn more, we'll be having some breakout rooms to further answer these questions. And here's a sneak peek of what the topics will look like and who from RockMass will be joining. But without further ado, let's get started and into our panel. So we have three guest speakers today, and our first is Ian McKillop. He is the manager of mine technical services at Glencore Kidd Operations. It's one of the world's deepest mines, and he's also been able to work with Glencore across their operations globally. He has really enabled Kidd to be put on the map as a technology forward site, and you'll see that by his background of all the wonderful pieces of technology that he's joined with us today. So welcome, Ian. Thank you so much for joining us. The second speaker that we have is Eliane Cabot. She is a senior rock mechanics engineer at Hatch, who has more than 20 years of experience working in consulting, engineering across not only mining sector, but also infrastructure and energy. So we are very excited for Eliane to join us. And then finally, we have Evan Jones. He is the director and principal engineer at a company called Enginex. He has a strong background in mining and metals industry, and he's a former principal geotechnical engineer at BHP's Australian operations. So Evan is so passionate about the potential of technology in mining that he's actually started his own company merging technology implementation into mining operations. And if that wasn't enough, he is also completing his PhD in mining engineering. So I'll give them a few moments to join us on stage now. Okay, everybody.
Hi, everyone.
Hey, everyone.
Thanks. Thank you
Hey,
so much
everyone.
for joining. So you're all here today to talk about technology and what Eon has in store. And you're really champions in this industry and within your organization. So maybe could we just start off by sharing an experience that you've had with implementing new technology and the benefits that you were able to see? Ian, do you want to kick us off here?
Sure, yeah. So I've been around here for about 16 years, and we've made a highly tech-enabled group. Got a long history of R&D and early adoption, and we see it now as a critical component of continuing to operate at extreme depth. We need that next order data and improving data over time to be able to keep up with what a reasonable expectation is of due diligence in managing a complex environment. And that's really where these kind of tools come into play.
Great. And Eliane, you're joining more from the consulting perspective. Do you have any kind of example or perspective to share?
Yes, for sure. Recently, I was able to work on a tunneling project in downtown Toronto for a water treatment plant, um, about 80 meters below ground surface, and we had the opportunity to use the mapper, the one that you have, and we use it in a very unconventional way. So that was quite interesting. Looking at not only the rock but also the defect in the concrete because this tunnel is lined, and displacement as well. So and volume calculation. So very
Mhm.
interesting.
Yeah, we've had some really creative opportunities to use our solutions together. And Evan, how about yourself? Do you have a story to share?
Yeah, so probably continue on from Ian's side of things. Having worked in a lot of data consolidation over the years, putting out numerical forecasting, KID being one of the minds I've worked with, had the fortunate experience there. We saw a lot of really good data being collected pen and paper, probably up until the 2000s. As computers have come into the industry, the limitations on what computers could actually take has meant that data was sort of pulled back a little bit. But now that we can actually incorporate a huge amount of data into forecasting, all these new technologies are collecting great digital data at quantities that we've never seen before, and quality and accuracy. And that's all really helping us improve our understanding of the RockMass. And something like this just goes along those lines of better data, more consistent data, in a way, in a format that can be used across multiple platforms.
Yeah, it seems like technology often gets the headline of all the different, ways that mining is going to or change. But really, when it comes down to it, especially with data capture, it's the people that enable the changes to be made. So, do you want to kind of talk about how you've been able to work with teams and motivate them on how to kind of take on the initial learning curve that there often is and see that bigger impact later on?
Yeah, probably one of the biggest challenges you come across implementing any new technology is you're taught ways through procedures, through your university degree. This is the way things are done, design is done, the inputs that you need. When something new comes along, you have a new data source, and you've got to work out how that new data can be implemented into new workflows or new design methodologies, and really challenge how you go about actually implementing it. So particularly things like LiDAR, which is used here as well. LiDAR is not really taught in universities, particularly not in a mining context, on how to use that in a design process. And unless you've got the time to stop, think about it, play around with it, develop it, implement it, understand the limitations of the data that you've got, you get a lot of roadblocks. And that, when you're in a fast-paced, moving environment in construction or in mining, can be the end of a project. Whereas if you work with research organisations, with tech startups, you end up with not only a set of data, but a solution and how to implement it without sort of having to go through that whole rigmarole of the research yourself. And that's probably the biggest impact I've seen uptaking new technology.
And Ian, Kid's been one of kind of highlighted as sort of a feature mind for adopting new technologies. What do you think has been so special about the teams that you've worked with?
I think that, we were lucky over time to have some people who were really keen on technology, and it does take a few of those people to, get something new and different into production, because you're going to run into, especially with very new things, you're going to run into some roadblocks and issues and things, but and you need people for those. But the most powerful thing that we've seen is making the tool valuable to the user holding it. If it helps them do their job, that's the most powerful thing to get someone invested in it. We've done that at our site, even with just with giving phones to people. We gave phones to people who had never used one in their life, and the deciding factor that makes them now not want to go to work without it is the fact that it's so useful to their day to day. And that's the kind of thing that we look for in solutions, whether it be something like the mappers we're talking about now, or remote scanning, or software tools. Even is, if it makes the user's job easier, it's going to be adopted.
Yeah.
Mm-hmm.
I agree with Ian. If I may, I was going to say that when we look at the outcome, this is actually encouraging us to go through those roadblocks, to be perseverant and try this new technology, try to change the way we are used to do things so that we can improve the outcome. Like Evan was saying, more reliable data, um, um, a greater amount of data with which we can perform statistics analysis or statistical analysis, and great input to our design. So,
Mm-hmm. Yeah, it's amazing when you see the impact that something can have. So we took a poll a few weeks ago on LinkedIn, and we asked people what they thought the biggest gaps in the mining industry were and how technology could help solve them. So this is the results of the poll. What do you think about this? Do you have any thoughts? Agree? Disagree?
I think the winning. I agree with the winning line. I mean, look, the technology is good at addressing a lot of things, and it's going to address the others. But the 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 emerging one, the emerging application, I think, is in the risk management piece of it. And mines are getting more complex, projects are getting more complex, and our ability to actually convey things like the associated risk is becoming critical. And again, back to our duty to continuously improve, we're doing really good at making mining construction safer to work in. But that's a progressive journey. So we really need to be tackling the risk and challenge piece of this using tools. I really think it can help us do that. It's helping us do it here at our site, so it can do it elsewhere too.
I'd like to add maybe another element that was not on your survey or that didn't come up.
Mm-hmm.
Personally, I think that there is a big gap in the collection of geotechnical data once a project is in operation or in construction. We do have relatively good coverage before, and so at the scoping level, PFS, FS level, with all the drilling data or drilling or borehole survey, and some surface mapping. But I would like to say that once we hit this construction operation stage, I feel like the level of data collection is dropping, and a mapper like this or new technology would definitely help over there.
I'd like to throw something on top of that too. I love this point, because we're really good at defining what kind of data we need when we have a project and we need inputs. But yeah, when we go into operation, we don't hang on as well to the purpose, right? But if we're doing something a little bit more forward, like we're doing a deformation-based support design here, and then as a result, the measurements and the data that you need to be able to do that becomes part of our day-to-day risk analysis, and it's going to be that way for everyone in the future, right?
We can probably expand on that. probably a little bit further too. A lot of the inputs are inputs that go into empirical analysis. And so there are a bunch of assumptions there. There's a lot of smearing of the information to create design charts. And you assume that the information that you put in is correct, but without doing some sort of feedback loop into reconciling the information through monitoring and then questioning your design, questioning your inputs, and whether they were actually relevant. I know in a lot of stoping cases, we'll collect a lot of information at a dry scale, which is what RockMass Eon is enabling and making that much easier. Prior to it's a lot of subjective data capture. One of the things I really see this kind of interesting and linking with the likes of the drones and LiDAR scans we see in stopes now is looking at things like scale dependency on our designs. So scale dependency of discrete structures. And so there's that feedback loop of, are our methodologies now actually the correct methodologies that we assume that they are? And we can only really gather that by collecting more information that is representative once we actually have access to those areas.
Yeah, I agree with that. And I was going to add that the borehole data is also very punctual. So having scanner also helps improve the range of the data coverage. So.
Mm-hmm. And I guess leading off of your question or your observations and getting a little bit more specific, what do you think the biggest impact of a mine or a tunneling operation adopting something like RockMass Eon could be? Ian, do you want to give your thoughts first?
Yeah, I think there's you're going to make a decision like that for a purpose. For example, we want to have the ability to put better calibration information into our modeling because it's the number one thing that controls how we decide where an area is too hazardous for a person to be. I think that impact is the obvious one. I think the biggest ones end up falling out when we do adoption is the second, third, and fourth order things that come out of doing that change. Like, for example, we've seen with a lot of tech adoption projects is the streamlining of 3 or 4 different people's data collection jobs, picking up more data than you need so that if you have to come back to it later, you can find information that you weren't looking for when you were there the first time. Those have kind of been the biggest game changers over time with adopting new methods of doing things, especially digital ones, right?
And so imagine that I had never been to a mining operation. What do you think, would this impact somebody that was a bit less technical?
One of the things in the mining industry, particularly more and more as we adopt covering everything in shotcrete, is you don't see the rock. It becomes almost a sensory deprived environment of everything is just concrete. Everything looks solid and stable. And having a record, a data capture of how many discontinuities, how varied that rock mass actually is, being able to show that information geospatially correctly, it's a really powerful tool to actually show how variable all your conditions actually are. It's not just a homogeneous concrete lined tunnel. Putting people at risk, by not understanding what's behind that concrete. If you then do a back analysis on that and be able to show these areas deformed because of these reasons and pull in that older information that you captured rapidly at the face, you then got really good data sources of this is what it used to look like, this is what's changed because of the mining front, stress front, and these are the outcomes we're now seeing. And so that really helps convey to non-technical people what was there and why you have issues or what the conditions are now and a reason why.
Mm-hmm.
I think
the idea of a sensory deprived environment is a really vivid one. Ian, did you have something to add?
Yeah, we kind of just went through or have been going through an adventure like this and looking to deepen our mind. So as mentioned, we're the deepest base metal mine as it is, and we're looking at a feasibility of extending it. And as part of that adventure, we had to go and do a lot of explaining to executives, decision makers, financial people, the people who don't understand a lot about this, but understand enough to know to look for the risks. The ability to go and take actual data information and do things like show how deformation-based support design works and how it prevents us from having people buried, or being able to turn around a high enough resolution geotech model that we can actually do a probabilistic model and tell you your chances of being injured in a seismic event. This was critical. I would say critical. Our project wouldn't go ahead without being able to explain those things to people outside of our SME groups. And we need the data to do that, right? You need the tools to be able to fuel those.
Yeah, visualization is the best way to convey your message, eh?
Yeah, it really does help tell a story and paint the picture. So speaking about painting a picture, I want us to now imagine we're in the future and it's 2040. Eliane, what does the average tunneling project look like in terms of technology?
Well, that's a big question.
Good question.
I'm not sure I have a crystal ball and I can tell, but I would say a little bit like Ian and Evan mentioned for the mining industry, we just want to push the limits further and further. So we want to do things faster, we want to go deeper. So which means that we have to adapt to all those environments that are either stressed or that have water inflow. So that's what we expect from the tools that are available on the market, that they can sustain those challenges and they can adapt to the different environment that we want to work in. So for me, when I have to pick a tool, I want this tool to be versatile, to be able to do more than one thing. So I can use it as much as I can. So mapping the rock, like we were saying for this mapper, but also consider that I can map concrete with it. I can look at volume estimate, because if I have the positioning of the pixel, the different point in my photo, I can create surfaces and then I can calculate volumes, or I can use it for the basis of my 3D model. So this is what I'm hoping for the future.
Do you think that the technologies used in tunneling and mining will begin to look more similar or more different? Do you have an opinion, anyone?
It's hard to say. I'm sure it's going to be the equipment's just going to be smaller and smaller and more resistant, more robust, I would think, and more powerful. But I'm sorry, I'm not manufacturing anything. So
What if we think about a mine in 2040? What do you think that might look like?
I think there's one.
And do you want to answer this one
robot.
first?
No, I think.
Oh, you go, Ian. Sorry.
Okay. I think there's one pretty clear thing that is certainly going to be different, and that's you're going to see little to no people in the work environment, right? This pathway to remote and the idea of remote first is emerging. It's starting to be a mandate in specific areas. It's starting to be a mandate of high risk environments, like would be in our expansion here. But you know what? This is one situation where equipment OEMs are miles ahead of everyone else in the process. So we have to get to a point where we can do everything else. It's great if a jumbo can drill around and we can load and blast it remotely. But then if the geologist has to go stand there with the color pencils and a piece of paper, then we've lost the benefit. And so anything that we're looking at now that leads us back to the thing that we're working on today has to sit somewhere on that roadmap from here to the future where there's no one in the mine. So, yeah.
2040 is not far off. It's 17 years. And you look back 17 years, and mining wasn't that much different. And so if you look at what 2040 is going to be, it's going to be a spectrum. You're going to have some mines that are going to be autonomous. You are probably going to have more mines that are block cave and sub-level cave that are easier to create an autonomy environment. You're still going to have a lot of mines on the other end of the spectrum, like artisanal mines or small stoping mines, cut and fill mines, that are still going to be done by hand. You're still going to have people at the mine face. So there's going to be a broader spectrum, that's for sure, in 2040. To your point, Ian, on autonomy, you can't get away without a geotech engineer. You can't get away without a geologist. Sure, you can remove people from boggers and haulage trucks, but if the mine isn't stable and you've got rockfalls everywhere, they can't operate. So you're still going to have a stable mine undertaken by robust geotechnical assessment. And so what does geotech look like in 2040? What does a remote geotech look like? So you don't have to stop operations to put a person down the face there. Think of Google Maps, but underground is probably a terminology. You want to be able to see everything everywhere. What sensors do we use for that? What's going to be available in the next 17 years? But LiDAR, camera, all sorts of other sensors will go into that. So, yeah, big challenge there. But what we need actually is more mine sites adopting technology earlier, because if you don't have the adopters, you can't progress. So people like Kid Creek, who are really forward in adopting technology, taking a risk in that technology, is really important to get us to where we want to be in 2040, in 17 years of no people underground. Because it's going to take a lot of trial and effort. I've been playing around this space now for almost a decade, and we still don't have a continual uptake across the board on LiDAR. And it's a really awesome technology that could be adopted more readily.
Yep, absolutely. And any parting thoughts from our panelists today about technology, the mine of the future, anything in that realm?
Like I really want to echo something that Evan said, and hopefully, relay it to as many people as I can, as I do every chance I get. But this point of having more people trying to do this is very important. And a thing we do in mining is wait until something shows up on a shelf at Best Buy, and then that's when we're happy enough to adopt it. And we can't do that if we want things to change. That can't be the way we go about it. And I encourage that's it. And go get the tool, go work with someone who will help you understand how to use it. And maybe some of them won't work, and maybe some of them will. And I can promise you that it works. And it'll help all
make
of us.
A difference. Yeah.
Yeah.
Oh, that's really inspiring.
But also open forums to discuss what does and doesn't work. Like I go down a pathway of these are the technologies I like, but just talking to Ian just recently, there's technology out there that I don't know. People have a wealth of knowledge. The construction industry, they've got new technology as well, and there is going to be a lot of crossover between them as we work out what's great, what's not. Let's rehash some other ideas too. Like I know I'm working with a couple of other technology companies. It's not cutting edge in the sense that we didn't know about it 2 years ago, but it's not adopted by the mining industry yet. And there's certainly some great upside on that technology if we can bring it effectively to the mining industry.
Absolutely. Well, thank you to everybody that is here today for your stories, insight, inspiration to try new technologies and to motivate their teams to do so. I know I've even learned something from this discussion here. So I want to thank you all for joining us today.
No, thank you.
You're welcome. Thanks for having us.
Absolutely.
Okay, so I am going to move on to hopefully a moment that you have been curious about and all waiting for. I will now would like to introduce the official release of RockMass Eon. So I think the video is just taking a couple. There we go. Okay, what did you guys all think? Let us know in the chat. I am here with Eon today. And so what is Eon? It is a portable LiDAR scanner that powers our in-house mapping application, Lithos. Now, Lithos enables geologists and engineers to map in 3D, georeference it in real-time underground, and then seamlessly sync it to any kind of software that you'd already be using, whether that's Sequent, Leapfrog, Deswick, Micromine Beyond, some more geotechnical applications like Itasca software, Rock Science. It works with everything. For me, I want to just highlight the three things that I'm most excited about here. So the first is the weight. So we've reduced the weight significantly. This is 3 kilograms, and it allows you to just really easily take it under a shift, underground for a full shift, and in my case, even run across the city with it. If you want to conceptualize what 3 kilograms weighs, it's kind of like a 6-pack of juice, bag of oranges, something like that. The second is the size. So I've carried mappers all around the world for a few years now, and I would always have to get on the plane and then put it in the overhead compartment, which is fine. But this one is so small that when I go on the plane, I can just tuck it in the seat in front of me. So really excited to travel with this guy. Now, the last piece is actually a tripod mount. So we have an attachment that allows you to mount it to a tripod. So this allows you to walk around, but it also allows for more accurate georeferencing. So you can turn it and tie into a survey point, then go and map the face, the back, the walls. You can even go like this. So it's really easy to move around and scan anything that you need to. And then when you're done georeferencing or you want to take it off, super easy to do that. So one last update that I'd like to share and highlight is those seamless integrations. So we focused a lot today on, especially in our panel, about the importance of data capture and the ease of it with something like Eon. But I also want to show you what happens and what kind of data sets that we provide. So I'll just take you through a really quick video of what some of our data looks like. Okay, so it looks like we have a few questions that I can hopefully answer. I'm going to actually invite Nicole to the stage, and she is an account executive with us at RockMass, and she'll just help me read the questions and I'll answer them. And if you have any other ones that you didn't ask, then you can always book a meeting with us. I think there will be a link going out into the chat right now. So Nicole, welcome.
Hi, everyone. Happy to be here, and thank you all for being here today as well. Yeah, make sure to post any last-minute questions in the Q&A chat. First question for you, Shelby. Is the Eon similar to the Axis Mapper, or is this a new tool that scans all walls at the same time? And maybe something else to add in there is any other key differences between the Eon and the Mapper?
That's a great question. So the biggest differences here is the portability, ergonomic size, and our accuracy in georeferencing. We still use a LiDAR sensor in a similar way that the mapper would be used. And one of our areas of focus moving forward is to be able to get those larger scanning windows and areas.
Next question. What is the maximum range of the mapper? Any increase from the most recent version?
The maximum range, we now have 2. If we look at the LiDAR instrumentation and what scans you can take in 3D, this will go up to 7 meters, depending on your environment and rock. And then if we want to extend the range to 2D, so that would be capturing any kind of georeferenced images, then that can go up to 30 meters now.
And what are the light requirements for the unit to take photographs?
So what we've done is we've actually removed the light from the from EON itself, and we provide a standalone floodlight. We found that this is the best way for us to be able to keep this nice and small and ergonomic while giving anyone the light requirements that they need.
And I know a lot of questions, or a common question we get asked a lot as well, is how can I see RockMass EON in person?
So there's a few ways. One is through the conferences that we're attending in the near future. So if anyone will be at PDAC next week in Toronto, we'll be exhibiting there. You can come and give this a try yourself. We will also be at the CIM conference in Montreal in a couple months' time. Now, if you want to see this tried out at your own site, then what you can do is get in touch with us to book a 2-day site visit. And think about this as a really easy, almost white glove service where we come to site, we show you how to use EON, we go underground and capture information, and then we help just sync it to the software you're already using and leave you with that data set as an example to see what's possible.
Another question we have here is, can you QA/QC ground support installation with it?
So we do have a ground support application. So what you're able to do there is go and identify any kind of support that's installed. And one of the videos showed one client that we've worked with has done so by saying, here's where the ground support needs improvement or needs to be remedied. You're also able to flag any features of interest. So that just brings that information right to the top, to the surface for somebody to action right away.
What is the size of the scanning window area that can be captured?
So if you're standing, for example, 5 meters back, then it's about a 5 by 5 meter area that you'll get the actual mapping surface. Now, when you export the point cloud, you actually are able to see a little bit more horizontally than that. So it'll be potentially at like 8 meters width and then that 5 meter height.
Okay, another question we have here is, have you tried wall mapping in an open pit situation?
That we have not directly tried because the mapper has been designed primarily for underground environments. The biggest consideration there is because the optimal range is up to 7 meters. So we've focused on it being an underground application. We've done some mapping on road cuts in the past, but not yet for open pits.
And does the system contain the ability to identify overbreak, underbreak, compared to the tunnel design?
That's not something that we currently offer. However, we do provide the georeferenced point cloud. So you would be able to take that into, for example, Cloud Compare and run your own calculations and analysis on it afterwards. And we just give you that baseline data set, but it's not something that we automate right now. And maybe, Nicole, is there time for one more question? If there is one?
Yeah, we can answer just one more here. Do the point clouds from individual scans cross-reference each other? to stitch or maybe georeference them together in correct 3D space?
Good question. So every point cloud file is about, if you imagine an image, it's like a 3D image. So it comes like this. And every single point has its own XYZ. So if you pull in one scan and then you pull in another one that was adjacent to it, they'll automatically overlap for you. You don't have to do any kind of stitching together that may be required with other technologies. Okay, thank you, Nicole, for helping me with some of the questions. And thank you for such wonderful questions. If you have more, then we will have breakout rooms where we have specific topics that will be covered. But I want to move on to one last exciting announcement, which is the door prize. So the person with the leaderboard spot has won an annual subscription to a professional association of their choosing. So let's see who this is. Brian Buss, congratulations. You are the winner. And so we will follow up with you on those details. So thank you so much for everyone for joining us now. Again, if you are at PDAC, we will be there. If you are at the CIM convention, we will also be there next. Again, thank you so much to our guest speakers for joining us today, and for everyone that was able to learn and listen in from all around the world. So I'm going to conclude the official end of the RockMass event. And again, there will be breakout rooms. So I'll just put up the themes of the breakout rooms really quickly. And so when I end the session, where you see me in this image of the live screen, they're going to be filled with tables. And each of those tables will have these topics, and you can join and leave as you wish. And you'll also find some of our guest speakers in some of them. So thank you again so much for joining us today, and we hope to see you soon.